It's time for Wise Guys Wednesday.
Yeah, U of I Professor Paul Kwiat is here to give us another lesson about magnetism, right?
Indeed.
Part 3?
Part 3,
We're
yes.
on part 3.
Part 3.
And matching bow tie and suspenders today.
Yes.
Extra touch.
Cool.
Love
Yeah,
it.
lots of disorder in them. We'll talk about that.
Oh, great.
So we've been talking about regular magnets, you know, things that are strong enough to pull up nails and things like that. And we saw a couple weeks ago that, for example, Cheerios had iron in them, so you could pull them along in water. Right. And then we started talking about the different types of magnets that there were. And so there's the first slide that we had here. Which talked about in normal, like kitchen magnets, it would be like ferromagnets, very strong things. And then at the other end of the scale, we had diamagnets. These are things like water, which are actually a little bit repelled from general magnets. They produce an opposite field, and that's where we were able to levitate the frog. We had the frog levitation video.
That was cool.
So today we want to talk a little bit about the middle category, these paramagnets. So these are materials that get a very weak, generate a very weak magnetism by putting a field on them, but then it goes away. So one of the examples of that is oxygen. And so I have this video, if we can show our first video. So it's hard to do with gas oxygen. So this is liquid oxygen that's being poured between the poles of a magnet. And you can see it's being held there. It's just, now it's evaporating, of course, but it's disappearing.
In between them, yeah. Look at that.
In between them. So I couldn't do this demo here because it turns out that it's not very safe to have liquid oxygen. So this was a video of a Russian tanker that had liquid oxygen, and you can see we didn't want that to happen to my car on the way over to the studio, so that's why I didn't actually do it.
I was wondering about that.
If that happened in here, that would be
so we
on the
can
top 5 list of disasters that has happened here.
Definitely top
exactly,
5.
so we want to avoid that. Okay, so I want to talk a little bit more about understanding what's actually going on in a real magnet, and so we want to understand what happens as I change the temperature. And we may remember from a long time ago, we talked about phase transitions, and that as the temperature goes up, we want to have things be more disordered. So for example, at low temperature, I have ice where the molecules can't move much, and then I have water, and then finally I have steam where things can move around a lot. So in a magnet, if we go back to the second slide now, in a regular magnet, at room temperature, all the little atomic magnets, this is on the left side, are all lined up with each other. And if I can get the temperature high enough, instead, I want to really, instead have a lot of entropy, I want to have everything be disordered, and then in fact, a regular magnet becomes a paramagnet. So in fact, it doesn't have much magnetism. If I can cool it down again, we'll get little neighborhoods, basically what are called domains, where the little atomic magnets will line up with each other. That will be like a typical nail. So it's not magnetic, it's not permanently magnetic, but it will stick to a magnet. And then finally, if I put it in a strong field, all those domains can line up again, and I can recreate my permanent magnet.
Okay.
Okay, so if we come back,
we're going to see this.
We are going to see this here, indeed, yes. So I have, if we zoom in over here, I have a little tiny magnet. Actually, first we're going to zoom into this guy, and this is just a, hopefully we'll zoom in. Great. So this is just a bunch of compass needles, and you can see this is like what the inside of one of those ferromagnets would look like if everything weren't aligned. So we see that they're kind of aligned with each other, but they're kind of disordered. Okay, so if we now go over to this, just to the side, just a little bit here.
Move over the camera a little bit. There you
go. Cam over a little bit. Great. So I have a little magnet which is hanging right there on the end of a nail, and I'm just going to heat it with a match. Hopefully.
You promised me no explosions.
I promise you no explosions.
You didn't say no fire, though.
I'm just going to heat it up with a match, and eventually, if the temperature gets hot enough, then all the internal, there we go.
There it goes, yeah.
Cool.
All the internal little magnets will not be pointing in one direction, and now I have something which, in fact, is not magnetic at all.
Wow.
And if instead I take that and I put it on a strong magnet, like I have here, then, in fact, if I do that, I can create something which, in fact, is, once again, a little bit magnetic. I don't know, a little hard to show.
So you kind of remagnetize it by attaching it to a strong
I've remagnetized it by putting it in a strong magnetic field. And this is a thing that can happen, for example, if you take a strong magnet and put it near your credit card, you can remagnetize the strip and erase all the information, which
Stay away from my purse,
is why you want to keep, for example, this magnet away from your credit card, because it will absolutely probably not give you $1 billion, probably give you nothing.
Now, does the same thing kind of happen with CDs or DVDs?
No, because those are all optical, and so those are completely immune to any kind of magnetic field.
Gotcha, okay.
They would happen like with an old cassette tape or something like that. If you draw a magnet across this cassette tape, then you can erase it.
Don't do that.
In fact, that's how they erase it. They just they run a strong magnet across it.
Cool.
Interesting.
Oh, thanks.
Yeah, very good to know. Thank you, sir.
Really cool.
See you guys next week for the
Final.
The
final
final exam.
Exactly, the exam.
Can't wait.
Exactly
It'll be
right.
magnetic.
Indeed.
Right? Well, still to come, you guys, this week is National Correctional Officer Week.
And coming up, you're going to find out how the Champaign County Sheriff's Office says their application process has changed and they have some upcoming recruitment opportunities.